Hello, this is Mike again from Fair Repair, and we have a customer job today. It is this nice Acer here. It is quite old. Normally I do not work on such old devices, but it is really a really nice device. Do you see the layout? You can actually pull the display to you however you want. This is amazing, a very interesting design. Have never seen something like that before. Very interesting. However, this poor laptop suffers from a short on the main power rail. At least probably on the main power rail. Because even if I simply inject 1 volt, it goes into protection already. So we have a serious issue, which even the benchtop PCU detects. And yeah, we have to open the device and yeah, let's see. So these were many screws. Let's see what we'll find inside. Can we open it? No? Is here something below? Yeah, another screw is here. Okay. Okay. Now. Right? Yeah. Okay, okay. And it has a GPU, which is bad news. I thought it has only a CPU. Let's remove the battery. Okay, okay, okay. Yeah, let us identify the main power rail. So, for example, at this buck converter here we have 2 MOSFETs and an inductor nearby. Oh, 1 second. Let's zoom a bit. Yeah, now. So, here we have an inductor and 2 MOSFETs. One is a high side MOSFET, which is fed from the main power rail, and the other MOSFET is a low side MOSFET, which is connected to ground. So only one of these MOSFETs is allowed to show continuity with ground. Alright? Beep mode. Good. 1.8 and 1.9. Internal resistance of the probes is 1.7, so the main power rail is shorted with 0.2 ohms to ground, which is a pretty clear short actually. I did not expect it being so clear. So a few sanity checks. This is probably the memory supply. Probably 3.3 and 5 volts. Battery charging rail, what do we have here? 150, so this is, what is this then? I'm not sure. Let's move further. 32 is good. 67 is good. And 100 is good. So this looks alright. 2.1, 1.8. And here 1.8, 2.0. Where can we inject? Where can we inject? 2 volt. Here, at this inductor here. Here we can inject. So let's move on and inject, I would say. PSU is already set to 1 volts. So then let's inject. And we have 2.5. Okay, so let's activate the thermal camera. So once again, here. Here, here. This one here. 1 second, let me show you. Where is it here? Can you see it? Here in this area. It is probably this one here. This one. Yeah, it is this one. So, easy fix. From where do I know where to inject? Well, pretty simple. We have checked at a capacitor on the main power rail. One side showed 2 ohms, the other side showed 1.8 ohms. The lower side is supposed to be ground, and the other side with 0.2 ohms higher resistance to ground should be the main power rail. So yeah, actually pretty simple math. So we have found a faulty capacitor. Let's see how we can get rid of it. So here we go. This one here does not look very suspicious actually, but it is this one. Let's check again in beep mode. Yeah. This one? No. These ones also on the same rail? Yeah, but it is a small ceramic capacitor. And what is that? It's bleeding? Huh? Interesting, huh? The stuff here? Okay. How can we remove it? This could work. Good. Oh, look here. Look here. It has something like a hole on it. Okay, good. So, should we look for a replacement? What is the board number? One second. So the first thing we will do is to check whether the short still persists. No, it is gone. Okay, it is gone. Same here. Nothing. Okay, so the short is solved. Let me look for a suitable capacitor. So this is part of the schematics for this board, and since the capacitor is near PC821 and PC822, it should be one of these ones here. Both are 10 microfarad with 0805 footprint, rated at 25 volts, so should be easy to find one. Good. Yeah, this looks solid now. Yeah, and this is also special, without any hot air action today. So I would say, let's have a look whether it is working. No? Okay, short is solved. Let's check again. Yeah, kilo ohms now. All right, good. So let's set up the PSU to 19 volt. Let's say 2 amps to start with. So 19 volts, 2 amps. Let's see. And does not draw any current anymore. Good. So charger is 4 amps something, so let's raise the current to 5 amps. Open the lid and pressing the power button. Where is it? Here. Let's go. I hear something. I hear something. Here we go. Fixed. Okay. It was a simple shorted main power rail. Nothing special. Nothing great to diagnose, I would say. But yeah. Also important to fix. Okay, let's shut it down. Let's see whether the battery is charging, and then we are done with the repair. Good, let's plug the charger. And nothing. So, we did a nice and a great job, but the battery is not charging. What could it be beside of a bad battery? It can be a shorted DC-in MOSFET, which is shorted between source and gate. Unfortunately, the area where the DC-in connector is located, let me zoom in, is here. And yeah, I can't spot the DC-in MOSFETs. So we don't want to waste time to remove the motherboard. How can we check else whether the DC-in MOSFETs are shorted? Probably we can check at the charging controller, because the gate pin of the MOSFETs is controlled by the charging controller. And we don't even have to check whether it is internal shorted. It is enough to check the voltage, because we know the current can flow through the MOSFETs. So there can't be missing gate voltage, but the voltage can be wrong because of an internal shorted DC-in MOSFET, and the board will still work somehow, but just not charge the battery. Let's check the charging controller. So this is a nice and small BQ24735, and the gate pin for the DC-in MOSFETs is here, pin 4. So let's plug the charger and measure the voltage there. This pin is supposed to measure 25 volts. So the MOSFET can open. What do we get instead? 19.6, which is literally the voltage of the main power rail. And this means the one of the DC-in MOSFETs is indeed shorted. I can't believe. So yeah, we have to remove the board anyway. So, board is out already. I've also talked to the customer, and yeah, the device was dropped earlier, even before he sent it to me. So yeah, we will not waste our time with these hinges, but straight to the DC-in MOSFETs. Let's see what we'll find there. I've not touched the tape yet, so now we will do. So in the upper right area here we have our DC-in MOSFETs. Yeah. So let's try to open it till some extent. Let's warm up the area. Around 190 degrees. Yeah, this should help. Let's see whether it helped. Oh, this is a horrible glue. Okay, so here we have memory for the GPU. Yeah. Okay, let's double check these MOSFETs. So, if I remember correct, we have measured a short between gate and source. And here we have the confirmation. What? So here we have 114 ohms between source and gate, and here the same. So now between source and drain, this one kilo ohms and this one 0.3. So this one is probably our shorted MOSFET. Let me grab a replacement. This will probably work much better. Yeah. Yeah, like that. Good, once again. Between source and drain, and we do have mega ohms, and between gate and source we have also mega ohms. Same with this MOSFET now, mega ohms. So this should be fine now. Okay, let's see whether it is charging now. So let's plug the PSU and power. 7 milliamps, 160, 0. 160. I call this charging current, my friends. This is charging current. $13.33. No. $13.40, 41, 42, continuously rising. So battery is charging now, just because of an internal shorted DC-in MOSFET. And just in case you still won't believe, the battery was not charging because of an internal shorted DC-in MOSFET. Yes, this happens quite often actually. So yeah, always check the MOSFETs, and if nothing turns out, then you should order a new battery. Okay. So this was charging, but what do we do about the touch display? Let's check whether it is turning on first. Hello? Okay, was not turning on. Maybe it's too low. Maybe battery is too low. This can be. What was that? $2.3 amps. I think the battery now dropped in to finally charge with high amps. Good. This is good. I think touch is working. I can see my finger. I can see my finger. Look. Can you see that? The dot, which is following me, it works. Yeah, touch is now working for some reason. I can't believe. How did I fix it? I don't know how I fix it. Touch is working absolutely fine. Okay. Okay. Now I can turn it off with touch. Or not? Or not? Now, it's just a bit slow because of the stone old hard disk drive. Okay? Let's turn it off. So touch is working. I don't know what happened. I have no idea. I did nothing except to remove the motherboard and put it back, replace the MOSFET. I can't believe that the MOSFET has anything to do with the touch. No way. It is buggy for some reason, but touch is working clearly. Oh, now it is shutting down. Okay. Okay. Cool. Cool. I'm happy with that. The repair is done. So we have fixed a shorted capacitor on the main power rail. Then we have fixed the battery not charging by replacing the first DC-in MOSFET. And by accident or coincidence, we even fixed the touch issue. The only thing which stays is the misalignment between the palm rest and the display because of the earlier drop. Yeah. Okay. Cool. As always, if you like my videos, I'm happy if you leave a like, a comment, or even subscribe to my channel. The tools I use are linked in the video description. Thank you for watching and let's see what comes next. Bye!